Alright, so I called my presentation Machine versus Machine because the movie I watched is about how the British at Bletchley Park managed to break Germany's unbreakable encryption device during World War II. So that movie is The Imitation Game, and so I just kind of put a summary of the movie here. And so it says, during World War II, the mathematician Alan Turing joins a team of code breakers at a top-secret facility at Bletchley Park to try to decipher the code of the German Enigma machine. Turing is a homosexual genius, and during 2 years, he and his team successfully developed another machine to decipher the Enigma. So basically, that's what the movie is about, is he is a genius who gets pulled out to try to solve the Enigma, which I'll explain to you what that is and how they solved it, because they wanted to just beat the Germans, and so if they could crack their code, that was the easiest way to do it. So Germany's Enigma machine is just this typewriter-looking device, and so every day at midnight, the Germans changed the encryption of their machines, rendering the past day's letters useless, and they don't send out a message until 6 a.m. with their weather report. And this was Germany's main form of message encryption before they sent it over radio so that their ships and other military groups could receive them to prevent interception and just the Americans and the British and all the other countries knowing their plans. And so all those militaries have access to the Enigma, and so that they can decrypt them, and it's supposedly unbreakable. And so then, the anatomy of this weird typewriter is really complicated, even though it doesn't look like it. So it has a light-up letterboard, which is this part right here that you can't really see. And so when you press, say, an X, the J might light up, or something like that, because no letter that you type in is going to come out as what you put in. It's basic cryptology, but it's just really weird. And so each keyboard has one wire that connects to one of those. And there are 26 wires, and they're all jumbled around in there. And those wires all connect to these rotors, which are placed up here. And so all of them would go into a spot that signifies a letter on this rotor, which then goes into this rotor and is jumbled again. And so it's 26 times 26, and then it goes through that all jumbled, and it goes into this one. So that's times another 26. So that's 26 to the third already, just options that it could be. And besides that, there's this plug board down here, and this is how the Germans would communicate, is they have a schedule. On this day, the chord is going to go from Q to D. And so they plug in this chord and it would go to here. And then they have W to C, and they would just have them all intermixed, but they have a schedule of when the chord is going to go where. But nobody else knows besides the Germans. Nobody else has that, okay, reprogram your computer at this time to do this thing. And so there were 10 plugs with 2 sides, that adds another 20. So that's 26 to the third times 20. And so now on my next slide, I do how many options of letters that actually comes out to. And so 26 keys to the third power for the 3 rotors, that is already 17,576 combinations. Each one of those rotors has 6 permutations. So if you remember anything about statistics, this entire movie is statistics. Yay, calc. And so basically, so you take that number, you multiply it by 6 for all the permutations that each rotor could have, and that brings it up to 105,456 options. And that's just for the first rotor, really. So I don't know exactly how to explain that because it's weird in my head too, but just know that. And then it goes in, that's just on this rotor right here, that goes into that one. Already there are 105,000. And then it goes to the second router, times another 26, over 2 million. Then you do the third router, and it's 71,288,256. That's without even using the plug board. As soon as the plug board comes in, there are over 100 million possibilities. So that is exactly, there are 159 million, which is that long, and there's an exact number, and it's 876. I don't even know what number comes after million, but that's how big it is. And that's how many combinations they have to go through. and they have 10 men and 18 hours to do that. And so this is just kind of an example of what you could do with this Enigma machine. It's just cryptology. I'm sure you guys would pass messages in code in elementary school or do something weird like that. Chances are you've looked at some sort of secret code messaging. And so there's a website that if you wanted to plug in random numbers, I put in A turns into an H, B turns into an S, and vice versa. And I just did that for the whole envelope or the whole thing. And hello, Abyss. Snack, Zot, Puss. Anyways, that's an enigma, kind of. And so, how long would it take 10 men to check 159 million possible combinations? 20 million years. And they have 18 hours. It is not possible. But who are they? Who are the men at Bletchley Park who are trying to figure out how they can possibly solve this? Well, they are spearheaded by Alan Turing. This group of men was gathered by the British government and an MI6. Really, there are only MI5 that was known about at the time, but there's an MI6 that's involved. It's super, super secret. That's how secret this project is. And so, Alan Turing was a genius and a homosexual, both of which become important to his life, but especially his genius. Because at the age of 22, he invented the Turing machine, which became the basis for all programmable computers, including the ones we use today. And it was based on the 0 and 1 binomial system. And he just came up with so many ideas that were ahead of his time. And so he proved, disproved, and improved many theories by other mathematicians, which didn't make people very happy because he was a pretty young guy. He went to Princeton University, and I think it's the Queen's College, but he was a fellow of the royal thing, like Jake just mentioned in his presentation. And he was also, with his basic computer knowledge, he also pioneered artificial intelligence and said that the human brain is an organized machine which through training becomes organized into a universal machine or something like it. And Turing's machine, as he improved it, eventually called his computer the universal Turing machine. So it could be programmed and changed and interact with other computers. And so that's basically just all of the things that this guy did besides everything that he did at Bletchley Park to try to end the war. And besides that, he was a homosexual, and so that was very illegal at the time, very taboo. And after World War II, after all of his work with the British, he was arrested for indecent exposure for being a homosexual, put on hormone therapy, and ultimately committed suicide at the age of 41 because he just couldn't handle it. And so there's a quote from the movie that I really liked that I kind of based my whole thing on, and he said, "Only a machine can beat another machine." And so Bletchley Park's first victory, that's what they called their first bomb machine, and this is what it looked like in real life. That's how they portrayed it in the movie, but that's what they used to break that code. So the anatomy of this bomb is basically, take one of those enigmas that I showed you earlier. There are 36 of them in this. There are 3 rotors, so if you go back to the slide before this one. There are 3 rotors in a column, and so each one of those is one enigma. And there are 36 of them, plus 1. But there are 36, and then that's the final. And then you can go back. So each one of them is an enigma, and there are 147 rotors on the outside, and they had to figure out a way to make all of these wires just interact, and so they came up with a diagonal pathway to make it more efficient. And so this is how it would be going. It would be just going down, down, in. It's all over the place, but then they made it easier where it was just 3 paths. And so that's just cutting it basically in half the distance traveled. And so basically, here's how it works. So in the morning, they receive their first 6 a.m. message, and it's all encrypted from the Germans, and it's just gibberish. and they have no idea what it says. However, the one thing they can count on is that I mentioned earlier, is at 6 a.m. they're receiving a weather report. And so if they know that at least the word weather report is going to be in it, they can use those letters to try to figure out where they fit in and how they fit into the thing, if you kind of know what I mean. I don't think my words just made sense, but so they call that word for weather the crib. And they use that crib to put the rotors in a general position to start, and so each one of those mini enigmas gets a set of letters. So A would be set up to E, or D would be set up to T, and it checks 17,500 positions until it finds a match that the machine thinks is logical. And once it finds this logical machine, it doesn't give you the actual answer to the enigma, because there's still so many possibilities that it could possibly be. So they have to run it through multiple times in order to find the correct letters, and then they have to put it through another littler computer to find everything. And in order to make all of this probability